purpose of this lesson is to learn how to use the while, for, and the do while loops, how to use nested loops, how to accumulate totals, how to improve loop performance, and also to learn how to use looping in GUI programs. A loop is a structure that allows the repeated execution of blocks of code. The block of code that will get repeated is referred to as the loop body. In C#, we have three types that we can play with. We have the while loop, the for loop, and a do loop, which is also known as a do while loop. Our while loop is going to be our most common type. This is going to be used to evaluate whether an expression is true or not, and then based on if it's true, then we'll perform a block of code. So if I'm trying to do something like count from 1 to 100, or I'm asking the user to keep doing something and I want to keep asking them for input until they enter some sort of sentinel value, then I'm going to perform some sort of action. So this is our body over here, and then this is going to be our evaluation for a Boolean expression. The while loop is going to allow us to continually loop as long as something is true. So I can do things like while the user types in a number less than 100, or while the user doesn't type quit, then I want to do something. Now what may happen is I can run what's called an infinite loop, and an infinite loop is going to be one where I don't necessarily exit from the loop ever. So what happens is I can have a definite loop and an indefinite loop, and those are the types that I want to use. A definite loop is going to be one where I know that it will run a specific number of times. The while loop is not really designed for that. We have the for loop, which we'll get to in just a few minutes. So a while loop is actually used for what's called an indefinite loop. And notice there's a difference between an indefinite loop and an infinite loop. Indefinite just simply means I don't know how many times the user is going to provide input. An infinite loop is one that the user can never get out of. So make sure you're aware there is a difference. So our while loop, we're going to allow for an indefinite loop. I ask the user, enter a number. Do you want to enter another number? Yes. Enter a number. Do you want to enter another one? And so forth. And we keep doing it until they give us something that says we're done. All right, so we need what's called a loop control variable. And in our case, we're going to call this a counter. It could also be something like a specific key that they have to press, or it could also be something where they have to type a specific value, and when they type that value, then it allows us to get out of the block. All right, so in this case, we have a variable called number that is equal to 1, and we've set a constant called limit at 5. So while the number is less than the limit, which to start with, number is 1 and limit is 5, we're going to say hello on the screen. And then what it does in this is it actually takes number, adds 1 to it, and sticks it back in a number. So now number is 2. Perform the loop again. 2 is less than 5, so it'll write hello again. Adds 1 to it. Now number is 3, and so forth. They'll keep doing that 5 times. Now in this case, this is a definite loop, and like I said, a while loop is not necessarily the best one for a definite loop, but it will work. It's just a little bit more work on our part. So in this case, we are providing a means for, we know that this will exactly run 5 times. In our program, it would look like this. So we initialize an integer called number, set it equal to 1, create a constant integer for the limit, set that to 5, and while the number is less than the limit, this should look a lot like your if statements. So I have the command here, it's while, this is our Boolean expression, and then we put the entire loop body inside of curly brackets. Now if we only have one line of code to be executed in our while loop, then we don't have to put the curly brackets. However, if you have a program where you're doing just one line of code, that's not going to be very common. So get in the habit of using the curly brackets. All right, so in this case, while the number is less than the limit, write to the screen or to the console, hello, and then increment number by 1, and then it repeats. Okay, now number is 2, increment it by 1, repeat, and so forth. Keep doing that 5 times. You have a problem, which I said you could do away with the curly brackets if you only have one line of code. And the problem that you'll encounter is if I were to do the exact same program without using the curly brackets, there are 2 lines of code that need to run with every loop iteration. My loop body should have both of these. But what happens is by not putting the curly brackets here, the while loop will run this line 5 times, just this one line. And then when that line runs 5 times, then it will run this line. So it'll look like this in the flow chart. We have the number is equal to 1, a limit is 5. Our loop would run writing hello 5 times, and then after this is done, then it runs that next line of code. Please get in the habit of using the curly brackets. It will prevent you from doing this. Alright, so we have another condition here, which is the number is 1, the limit is 5, and while the number is less than the limit, repeat. We'll keep doing this, and it's always going to be true because no matter what, 1 is always going to be less than 5. We're not doing anything with our control variable. Alright, so our control variable number here needs to be incremented, which means that we need to add 1 to it every time we go through the iteration, or maybe add 2 to it, or whatever stepping value that we want. But if you were to do something like this, this is consistently going to be true, and therefore it will never exit the loop. You'll end up with an infinite loop. Alright, so we could have an empty body, and an empty body is one where there are no statements in it, and this almost always causes an infinite loop. We have the control variable. We're going to either increment it or decrement it. Remember, increment means to add to it, decrement means to subtract. And then we have a stepping value, and our stepping value is going to be how much do we want to increment by. So if I do something like number equals number plus 1, then I increment by 1. If I want to do count by 2's, if I want to find all the evens and all the odds, then I would do something like number equals number plus 2. My stepping value would be 2, and I'm still incrementing it because I'm adding. Alright, so we have our definite loop. We know how many times that's going to run. And then, like I said, the indefinite loop, this is where the while loop shines, is one that we don't necessarily know how many times it's going to run, but we're going to typically allow it to be altered by user input. So maybe we're waiting for them to click on something. We might be asking them to type a specific value, or we may be waiting for an event like a timer or something like that. But there's going to be some sort of external event that occurs that typically causes our while loop to exit. Alright, so we have a program where we have a bank balance of $1,000. We have a constant double for an interest rate, which is 0.04. We have an input string the user is going to put in. We're going to ask for a response. And so we're going to ask the user, do you want to see your balance, yes or no? Take the response, put it into input string. Alright, so yes or no. Alright, so we're expecting them to either put a Y or an N. And in this case, it's only evaluating for capital Y. Remember, we have to evaluate for capital and lowercase letters. We're going to take their input string. We're going to convert it to a character and stick it into response. So while the response is equal to Y, do all of this stuff in here. And then what it's going to do is it's going to write all this out to the screen, showing them the outputs. And then it will say, have a nice day. So what this does is we're using this while statement kind of like a selection statement. And what I mean by that is that in this case, we're not asking the user to repeat something. We don't necessarily want them to see their balance 1,000 times. In this case, we're using the while loop only if they replied with a Y. So it's kind of like an if statement. We're using it like a selection statement, but it is a while. And what this does for us is it makes it where we can reiterate this again. So if we want to, we could repeat this section of code. Alright, we have a for loop, and a for loop is going to be a definite loop. And it's a shorthand way to do it. I can make a definite loop with a while loop, but it's going to take me extra steps to do it. A for loop has a couple of sections. It has the variable initialization, it has the conditional statements or evaluation that we're testing for, and then it has how we update the control variable all in one line. Alright, so what we're going to do is we're going to initialize an counter in the one line. We'll perform an evaluation to see if two conditions are true or not, and then we can perform a line of code and then we can test it again, and it will keep running until we get to the end of our definite loop. Alright, so I can also decrement, so maybe I want to count down instead of counting up, and so I can cause it to do other things instead of incrementing. But typically we're going to use a for loop to either count up or count down a specific number of times. Alright, so we have a for loop here. We're declaring a variable called x. We are setting a limit of 10. And then what it's saying is x is equal to 1 here. So what we're going to do is initialize it. And while x is less than our limit, so while x is less than 100, we're going to write something out to the screen. We're going to write the number x, and then we're going to add 1 to it. Now this is a prefix increment. I will show you the difference between a prefix and a postfix later. So the difference here between the while loop and the for loop is our for loop is one line for all of the code to initialize x, to initialize our counter, to evaluate whether the counter is less than the limit, and then to add 1 to the x. So what I can do is I can do this all in one line, initialize a counter, evaluate something, and then increment our counter. And then we just simply write out this one line of code. Now our for loop can also use curly brackets just like our while loop does, and I would like for you to get in the habit of doing that. But if it's only one line of code that it actually has to do, then we can just leave it without the curly brackets. Like I said, for now, use the curly brackets though. Alright, we also have a do loop. Now a while loop and a do loop are almost exactly the same. The difference is a while loop says while this condition is true, then do something. Alright, so a do loop is reverse. A do loop is do this stuff first and then evaluate to see if that condition is still true afterwards. Alright, if you've played with flowcharts before, in your flowchart you have the diamond as your conditional to get out of the loop. And there was a difference between if you put assignments above the loop control and below the loop control. So if you put it above the diamond or below the diamond, it made a difference on how things were calculated. So what we're going to do is we're going to decide if we want to only run this thing so many times until the user types quit or types some sentinel value. Then we're going to usually use a while loop. But if I want to do something like ask the user to run a program, and maybe we're going to charge them because they want to look up their balance, then what we might do is run the section of code that will look up the balance. We will take the money out of their account and then ask them if they want to see it again. Alright, so in this case I have a while loop that my while loop is waiting for a response, and if the response is y, then we will display the stuff out to the screen. In a flowchart, it looks like this. So we have our loop body. In the while loop, the evaluation for the loop body would be down here. In our do loop, we move it up here. So essentially what would happen is that it performs all of the functions of the loop body first, and then it will test to see if the condition is true. Alright, so in this case I have something like this where we're going to write the bank balance, we're going to perform a calculation, we'll write more stuff, get a response from the user, and then we decide if they want to see it again. So no matter what, we're forcing them that very first time to see the information, and then we can say, do you want to see it again? Yes or no. Alright, so in the while loop, I give them the opportunity to make the decision, do you want to see it? And they have to say yes before they can see it. In a do loop, we show it to them, or perform whatever the calculations are, and then we ask them, do you want to see it again? Alright, so we can use nested loops, and a nested loop is just simply where we take one loop and put it inside of another loop. Now we have an inner loop and an outer loop, and we have to pay real close attention to where our curly brackets exist. Our loops have to be properly nested, which means I create an outer loop, I open a set of curly brackets, and then I type the other loop inside of those curly brackets. And it has to be that way. Alright, so the entire inner loop has to be entirely contained within the outer loop, and they can never overlap. Alright, so in a flowchart it would look like this. So we have a loop, we're testing the outer control. So we're going to test something that was true, so then we go into the inner loop and test something and then perform this loop. Then when this loop is done, then we go back out and then we run the first loop again. So the outer loop runs first. The outer loop then calls the inner loop. The inner loop does whatever it needs to do. When it's done, then it goes back to the outer loop. Alright, so in our code it would look like this. We have a for loop where we're performing some function. It has some calculations and some things that need to be displayed on the screen. And then inside of there we have another loop where we want to display more information. So in this case what it's going to do is it's going to set the starting balance to our bank balance. We'll write out to the screen the starting balance is, and then whatever the bank balance was as a currency string. Then we display the interest rate, And then the next thing that we're going to do is we're going to display it for several years. So we can display all that information for all these years. We actually nest them inside of each other. By doing this, my code would give me output like this. So my starting bank balance is this much, and if the interest rate is this much, this is what I would have after year 1, 2, 3, 4, and 5. If the interest rate were 6%, then these might be my balances. So I don't have to type all of these lines of code. It's a repeating calculation that occurs, so we just let the program do it on its own. We need to keep what are called accumulated totals, and accumulated totals are also referred to as a register. Now, a register is a place where I just store information temporarily, so that way I can keep track of a total, or I can keep track of an average or something like that. So I'm just simply allocating a place in memory just to temporarily hold a value so that I don't forget it when I repeat my loop, or if I exit the method or something like that. Now, these could be a local variable to the method, or they could also be global variables depending on what all methods need to have access to it. Alright, so what happens is when I create an accumulator, it's known as garbage, and the reason that it's known as garbage is that all it does by simply initializing the variable, declaring the variable, is it allocates memory for it. And one thing you need to remember is behind the scenes, your memory already has ones and zeros in it. So if I take a block of memory and I don't assign a new value to that location, then the value is actually whatever was in that memory location originally. So if it's a whole bunch of ones and zeros, it'll read that value in and say, oh, hey, it was supposed to be whatever that value is. All right, so what happens is whenever we use a register, we have to initialize it. We have to provide an initial value for it. So what I'm going to do is something like int register equals 0. I just have to give it some initial value, and then what it does is it will take that memory location and set the value to 0. If I try to use a register and I don't initialize it, the compiler may not allow me to actually compile my program. Alright, so in this case we have a double to hold a purchase, and then we have a total which is set to 0. We're asking for an input string, and what we're doing is we're setting a value of 0 to quit out of the program. So what we're doing is using a constant to hold our conditional evaluation statement. Alright, so we're going to ask them to enter a purchase amount. We enter that amount, we put it into input string, and then we convert the input string to a double. So now purchase now has a value. So before this while loop occurs, any variables that are going to be used in here have to have a value, or else it will not compile. Alright, so while the purchase amount, let's say I put $10 in there, is not equal to quit. So if I ask the user enter a purchase amount, and they enter 10, if the purchase amount is not equal to quit, which is 0, then we're going to perform these functions here. So what we're going to do is we're going to take the total, and then we'll do total equals, remember this is our shortcut, total equals total plus purchase. That's what that stands for. Alright, so then what we're going to do is enter next purchase amount, or press 0 to quit, because it'll replace this. Alright, so then we read in what they type, we put that in the input string, and if they didn't input 0, we're going to ask them for another amount. And we'll keep asking them for an amount until they finally get to 0. But like I said, what you need to pay attention to is anytime I initialize one of these variables, it has to have a value in it before we get to the loop. If it doesn't, it will not compile. Alright, so in this case, it will ask the user, enter a purchase amount, they entered $5.10. Then it will say, enter the next purchase amount, or 0 to quit. They enter $12.87, ask for another one, they enter 100, and it asks for another one, 0 to quit, they enter 0. So now 0 is equal to 0. So now our condition is false, because remember it was while the purchase amount is not equal to 0. So now while 0 is not equal to 0, now it's false, so we're going to exit the loop, and then we simply put the last line of code that tells us what the purchase amount is. Alright, so some things that we can do to make our loops more efficient. We need to make sure that our loops do not have unnecessary statements that will run over and over and over again. Alright, so in this example we have a while loop that says while x is less than a plus b, perform whatever's in the loop body. Every time this while loop runs, it will have to reevaluate what a plus b is. So a better way to do this would be to create a new integer value called sum, add a and b together, and then set it where while x is less than sum, then perform the loop body. It speeds up our program because this one has to evaluate a plus b every single time. This one only has to evaluate a plus b one time. Alright, so we can do some other things where we can short circuit operators. Now what will happen is sometimes we're going to tell the user enter 0 or 999 to quit. And what we may do is we may ask the user to enter one of those, and if it's more likely for them to enter 0 to quit, then what I want to do is I want to put that as the first conditional statement. So what will happen is, in this example, we're asking the user to enter a number of printed copies desired between 1 and 15. And it's really likely that their value is going to be greater than 15, and not necessarily as likely to put in the other way around. It's more likely that they're going to put a value between 1 and 15 and not necessarily that it would be greater than 15. But what we have to do is we have to evaluate that. We want to make sure that they don't enter something bigger than 15, because if they do, then we want to exit. Alright, so what we're doing here is if we evaluate if the number that they enter is greater than 15, that's going to be less likely the input that they're going to put in. So what will happen is it'll evaluate this one. Let's say they put in a number of 5. I want 5 copies. Alright, so I put 5 in. Is 5 greater than 15? No. So then it has to evaluate this. And what happens is by doing this, then we're simply telling it that, well, we're going to evaluate some number that may not occur very often. This one's much more likely, so let's put this one first. And then what happens is it'll evaluate just whatever the first one is, and if this one is true, then it would run. So what we're trying to do is we're just trying to make it where it doesn't necessarily have to evaluate both conditional statements, only the first one. We also have this thing where we need to compare numbers together. And a lot of times what we'll do is we'll ask the user to enter 999 to quit or something like that. And the thing is that the system actually has a performance issue when it evaluates numbers that are not 0. So what we usually want to do is if it's something where the user is not actually going to enter a 0, so let's say it's something where they're supposed to be depositing money into an account, well, they're not going to enter an amount of 0, so we can use 0 as our exit condition. And what happens is if I evaluate the 0, it'll actually run faster than if I evaluate it for something like 999. Alright, so we want to compare to 0. Alright, so what that means is in this one, this is a stopwatch program that's, a stopwatch object that is supposed to keep track of how long it takes for this particular function to run. So we have a for loop where we start off with a counter of x at 0, and then while x is less than loops, which is, let's see, 1,000,000, we're going to add 1 to x and see how long it took for the stopwatch to run. So we have a second stopwatch, and the second stopwatch is a for loop where we start off where x is equal to loops and we count down to 0. So what happens is we're evaluating 0 as one of our conditions. Well, the reason that it is faster to count to 0 is 0 is a definite value. Anything else is either literal or a constant or a variable. Alright, so in this case it has to do a lookup every time to see what loops is. So it goes up and says, oh, loops is this amount, let's put it there, then we'll do the calculation. So when you run this, there's a difference. This one is starting at loops and counting down to 0, so we only ever have to evaluate x and 0. This one starts at 0, and we have to evaluate x and loops and do a lookup every time. So what you actually find is that exact same program counted the same number of characters, but it the first one counted up, and the evaluation was to count to the maximum number. This one counted down to 0, and the evaluation was x versus 0. And you'll see that this thing actually ran 5 milliseconds faster than the one that counted up. Alright, we can also do things called loop fusion, which loop fusion is just simply a technique where we can take 2 loops and try to combine them together. Sometimes what you'll get is you will actually have a loop where we perform a couple of calculations in the loop and we need to run it, say, 5 times. And then we'll do another loop where we need to count 5 more times. Well, instead of doing those as 2 separate loops, sometimes it's better to put those as one loop and put all the statements into that body. It's not always possible, but sometimes we can combine our loops together, and if we do that, it'll make our program run faster. There are going to be times where you have to do things like ask the user for input so many times, then we display output so many times, and if that's the case, those won't necessarily work without doing some other programmatical changes. But if it's just something like I want to ask the user, do you want a value, and then we say something back to them like hello so many times, then what we could do is we could actually ask them a question, do you want to see hello? Yes, and then display yes. And so we could actually put the two loops together and make our program run much faster. Something else that we can do is we can use prefix incrementing rather than postfix incrementing. And this is going to be what we're going to use for for loops, because remember, our counter, we need to increment or decrement our counter. And the prefix versus postfix, I'm going to show you here in just a couple of minutes what the difference is, but the prefix one is the one where we do something like plus plus x. Alright, so in our program here, we're going to do the exact same thing we did before. We have a stopwatch, and our stopwatch is counting from 0 up to 1 million, and we have a prefix operator here, so we're saying add 1 to x, and then perform the calculation. And then this one here, we have x, and then we add 1 to it. Alright, so what we're doing is the exact same number of iterations, but what you can see is that the one where we do the prefix actually runs much faster, 6 milliseconds faster. Alright, so we're going to start using loops with our GUI programs. And some of the problems that we'll have with the GUI-based programs is that you'll run out of room on the screen. You'll have things that go off the side of the screen, so we need to take those into consideration. And we're going to use our escape sequences like new lines and stuff like that. So what we're going to do is we're going to have to code these a little bit differently. Now, in our console-based application, we typically have to ask the user, do you want to enter another one? Do you want to enter another one? And we have these lines of code asking them, do you want to? Then we have to convert that to some value, and then we have to do an evaluation. Well, in our console-based application, typically we have a button that says calculate. And then every time they press that button, then it performs the function. So what you'll actually encounter in this case with the loops is a lot of times we don't necessarily need to use a loop, and if we do, we actually end up with a lot less lines of code. Alright, so in this case we have a value here, how many times do you want to see the greeting, and then they click. And when they click, then it will display on the screen that output a certain number of times. So as a loop, we take this 5 and display it out to the screen. Now I could have accomplished the same thing by getting rid of this text box and then just making it where every time they press the click button that it displays hello on the screen. But here I'm asking them how many times, so it's the same as them clicking this 5 times. Alright, so in our program we have the textbox.text. We're going to convert it to an integer and we're going to stick it into the num greetings, so the 5 that was entered. Then we have a counter, and our counter is going to start at 0, and we're going to count up to the number of greetings, and we're going to increment by 1 every time it runs. Now it is possible, our counter right here, we can actually declare our counter here. So we could do away with this line completely. So what we could do is we could say 4, and then inside of here int count equals 0. Now the problem with that is going to be if I need to use this counter again later, then I can't reuse the same variable name. I would have to create a new one. Alright, so in this case, if I'm going to use this counter more than one time, then I want to declare it outside of the loop. If I'm only going to use it that one time for the loop itself, then I can declare it inside of the loop. And so what happens is we start at 0, we count up to 5, we increment our counter by 1, and then we just simply display hello with a new line character. Alright, so we could do something like, do you want to see your new balance? And every time you click yes, then it would display the information on the screen. So I have the option of either asking them, do you want to see your loan balance 3 times, or just let them choose how many times they want to see it because they can keep clicking yes. Now the problem that you'll have with this is going to be that if they click it enough times, it's going to keep making new line characters, and eventually it's going to go off of the screen. And typically what would be better than making this new line character is completely replace the text that's here with the value. So the first time it would say bank balance is 1,000. Then the next time they click yes, then it would overwrite bank balance is 1,040. Then when they click yes, then it would overwrite bank balance is $1,081.60. So we need to take into consideration the way that the user is actually going to use the program and what kind of output we would like for it to see. Alright, so in this case, we can just simply say that the output label.text is equal to, and then we're adding whatever was in the string originally back to the output text. So instead of adding them together and simply creating new line and new line and new line, I could just flat out replace the text with this value. Alright, so I want to start making some programs. And so I have my chapter 5 folder, I have my template and my command with path. I'm going to make some console-based applications. So for right now, this is going to be my Pringle underscore week 6 underscore number 1. Editing it with Notepad++. And what I want to do is I want to make a program that asks the user to enter a number. Alright, so what I'm going to do is I'm going to ask for the input for the number, and then we're going to simply output the number on the screen. And we'll modify this a little bit as we go through it. Alright, so what I want to do is I want to, this is going to be our declare variables, and then I want to ask for a number, and then I want to display the number. And the question is, how many times do I need to do this? So I'm going to ask the user to keep entering a number, and I don't necessarily know how many times they're going to enter a number. So what I have to do is I'm going to declare a variable to hold the number that they're going to enter. So I'm going to create int, let's say input number, and then I'm going to have a constant integer that's going to be equal to some sort of exit condition for my loop. So I'm going to say constant, and this is going to be an integer, and I'm going to call this int quit, I'm sorry, all capital letters, and we're going to set this equal to 999. So if they enter 999, then we just simply quit. We're going to stop asking for numbers. Alright, so we're going to ask for the number, then we're going to display the number, and then we're going to allow them to enter another number if they want. Alright, so this is actually going to be the inside part of our loop. So if I were to do something like this, there is the inside part of our loop. Alright, so we're going to create a loop. Okay, so we're going to have a loop asking for the number, and inside of that loop, we're going to perform these functions. Alright, so I need to start off with my while loop. And so what I'm going to do is while int input number is not equal to int quit, then we're going to ask for the number and we'll display the number. Okay, so what I'm going to do is I'm going to say while, and then inside of parentheses int input number is not equal to, and then int quit. Alright, so I want to perform some stuff. So what I'm going to do is put it inside of curly brackets. Now remember, like I said, this is the stuff that belongs inside of our loop, so I can move this up here. And that helps me remember what I need to put inside of the loop. So I'm going to ask the user for the number. Alright, so what I want to do is I want to prompt them, console.write, and then I'm going to say enter a number. And then what I'm going to do is provide them with some sort of prompt. So I'm putting the arrows just to point over to say that's what we're doing. Okay, so we ask for the number, and then we're going to display the number. So we need to somehow write that out to the screen. Well, what I want to do is I want to take whatever number that they enter, and they've entered something, and I want to put it into a variable location. Okay, so what I have to do is I have to read in whatever they type. I have to convert it to an integer and stick it into int input number. Alright, so I'm going to say int input number is equal to convert.toInt32. And what am I converting? Well, we're converting whatever we read in. Oops. Okay, so read in whatever's on the line from the console, convert it to an integer, and stick that into int input number. So now what we're doing is we're taking the number and we're going to allow the number to be output to the screen. So now this has to be a number because up here I'm going to perform a calculation or a comparison to see if it's equal to our quit variable. Alright, so if we take the number in, then what I can do is I can say console.writeLine, and then we could do something like your number is like this, and then we're going to put in int input number, and that's our display. So we're asking them for the number. We convert it to integer. So we ask for the number, convert it to an integer, and then we display it back on the screen. And we're going to keep doing this until they finally enter 999. All right, so the problem is I say enter a number, and I'm not giving them any other information. So what I also want to do in here is I'm going to say enter 999 to quit. And then what this does is it provides a prompt to the user so that they know how to get out of my program. All right, so I'm going to save this. I need to compile it, so I'm going to use my command with path. And it's CSC, and the program that I'm compiling is Pringle week 6 number 1. Compile. All right, now it says use of an unassigned local variable on line 14, so I need to go check that out. And on line 14, I have int input number. This here is not equal to int quit, which is here. And the problem is that our int input number is unassigned right now. What that means by that is that our variable, before we get into the loop, has to have a value. Remember I said before, you have to have some sort of value in that memory location. So our int input number, we're going to start it off at 0. And so now what we do is we assign a value to this memory location, and now the first time that it runs, it'll say while 0 is not equal to 999, then we're going to do this down here. All right, so let's try it again, compile it, and it worked. Okay, so now I can run it, and we ask for a number. So I'm going to say 50, your number is 50. Okay, we enter 60, 100, I can enter 10,000, 100,000, however many I entered, and then it's going to keep asking me until I enter 999, and when I enter 999, then it quits. So the idea here is that I keep prompting the user for input the entire time that they are typing the numbers in, and then we just keep outputting it and ask them for another number. All right, so let's go ahead and save this as number 1, and then I'm going to go to File, Save As, and I want to name this number 2. So we're going to name this as number2.cs. And so what I want to do is I want to modify this a little bit. Instead of just simply asking for the number and outputting it, I also want to keep track of the sum of all of the numbers that they enter. So what I'm going to do is I'm going to create another variable, and I'm going to call this int sum. And once again, I'm going to start this off at 0, so I give it an initialized value. And what I want to do down here is I don't want to say your number is, I want to say the sum is. So the sum is 0. And this isn't going to be int input number, this is going to be int sum. So we're going to display the sum of the numbers. Okay, so this is my desired outcome, is to have the sum of the numbers. All right, so what happens is I just created a register, an accumulator, and what we're doing is we're going to simply take whatever the value is that the person inputted and put it into int input number. All right, so if I do something like, I'm sorry, not input number, int sum. So if I say int sum is equal to int input number. All right, so what this will do is if they enter 5, it'll take 5 and stick it into int sum. Run through again. They didn't enter 999, so if they enter something like 10, then what it will do is it'll take the 10 and stick it into int sum. And I didn't necessarily want that to occur. I want this to keep adding up. So what I'm doing is I want to do something like int sum is equal to whatever's currently in int sum plus int input number. So now the first time we run through it's 0. So 0 plus, and if we enter 5, is 5. And then put that into int sum, run through again. Now int sum is 5 plus, and we inputted 3, so now we put 8 into here. We keep doing this, we keep adding to it. All right, so this is the longhand way to do it. I can actually take this, and I can do the shorthand by simply putting a plus equals here. So this is the same as saying int sum equals int sum plus int input number. So now what we're doing is just simply providing a means for asking the user for the input and add it to our accumulator. All right, so I want to compile this. I need to save it first. And this time I'm not compiling number 1, I'm compiling number 2. All right, and then I want to run number 2. All right, so we're going to ask them to enter a number. So I'm going to enter 10, and the sum is 10. Now, it's 10 because it originally started as 0 and then added 10 to it. So now I'm going to add another 10 to it, and now the sum is 20. Add 50, and so forth. All right, so what I'm going to do is I'm going to type in 999. And what I expect to happen is for the program just to simply quit, and we're done. The problem is it took 999 and it added it to our sum. The problem is the way that I'm asking the user for input. So what I'm doing is I'm asking them, or I'm evaluating, if these aren't true, then we're going to do something. So what I want to do is not necessarily evaluate first and then do something. I want to do something first and then evaluate. So sometimes a while loop is the better way to go. Other times a do loop would actually be better. So what I'm going to do is I'm going to make this into a do loop. And what I'm going to do is I'm going to take this while out of here. I'm going to cut it. And I'm going to come down here right after the last curly bracket and paste it. And then I'm going to come back up here and I'm going to put do. So now what we're saying is do this stuff, then evaluate. Then we do all this stuff and evaluate again. All right, so let's try to run this and see what happens. So I want to compile it. Okay, it's saying that something is expected on line 22. Yep, I forgot my semicolon. All right, so we're going to compile it and run it. All right, so I'm going to put in 10. Sum is 10, 10, 10, 10, 10. Okay, so I do 999, and I get the same thing. Now, the thing is that what I'm doing is I am taking my my sum and I'm adding it to the input number every time, but what's going on is that I'm doing it inside of the loop. So by doing this inside of the loop every time, it's going to keep adding it to it. So I have a couple of options. One would be to deduct 999 from our value. The other option would be to reorganize things. All right, so I'm looking at this and I want to try to make it where if they enter a number that's not equal to 999, then I want it to actually increment our amount. And so what I'm going to do is I'm going to modify this line of code right here. And what I'm going to do with that line of code is I'm actually going to put it inside of an if statement. So I'm going to say if, and then int input number is not equal to 999, then I want to do this line. I don't want this line to run unless this is not true. So what will happen is if I enter 10, 10 is not equal to 999, so we're going to increment this. If I enter 999, this is false, so we'll skip this line and go right to the sum is. Alright, so by just simply putting that if statement there, let's try it. And then when I run it, now we'll do 10, 10, 10, 10, those work. But if I do 999, the sum is still 40 because I didn't perform this calculation because that would be false. So I need to pay attention to not only the order, but I also need to pay attention to should I perform that calculation. And so you will end up with things where you have nested if statements, you end up with nested loops, and the whole intention here is just simply to make it where I don't get a value at the end that I shouldn't have. Alright, so we're going to go ahead and just save this one. This is number 2, and then we'll go ahead and make number 3. Alright, so for number 3, I'm going to copy my template. And this is our Pringle underscore week 6 underscore number 3.cs. And in this program, what I want to do is I want to count from 1 to 100, or let's say 1 to 20, so that way it fits on the screen. Alright, so what I'm going to do is I'm going to make a for loop. Now my for loop starts off with a variable, and what we're going to initialize the variable as. So in this case, we're going to do a counter. Now in previous classes, we've used counter or my counter or something like that. Well, the standard way that most people write counter is just simply the letter K. And I'm going to start my counter off at 0. Alright, so then the next thing that I want to do is while K is less than 20, that's my evaluation. What do I want to do? So every time this thing runs, I need to do something with K. So I'm going to add 1 to K every time it runs. Okay, so now I'm going to do this for statement. Get in the habit of the curly brackets. I don't necessarily need them for this one because I'm just going to make one line of code. But what I want to do is I'm going to do console.writeLine, and the output is just simply going to be k. Alright, so now the problem is I have this variable called k, and nowhere have I declared it, but what I can do is I can actually declare it right inside of here. So I'm taking this integer value called k, setting it equal to 0. This is the same thing as declaring it up above. The problem is if I have another for statement later that uses k, I can't redeclare k later. So I have to pay attention that this is already declared here, and then in my next for statement I would just start off with for k equals 0. Alright, so what we're doing is we're starting with k is equal to 0. While k is less than 20, add 1 to k. Save it, and then I'm going to compile it. Alright, so in this case we're doing 3. I want to run number 3. And there we go. So what it did is it just simply displayed all the lines from 0 to 19. Okay, so the question is, why did it do that? I didn't want it to display 0 through 19. I wanted it to display 1 through 20. Alright, so what I need to pay attention to is how I actually declare this. So 0 is going to be our first number. Alright, so what I'm going to do is set this equal to 1. And then I want to count up to 20, so while k is less than or equal to 20, then we can increment it. Alright, so let's try it again. And now we get 1 through 20. So we have to pay attention to not only how do we start it, how do we initialize our counter, but we also have to pay attention to how high we want to go. Do we want the actual number, or do we want the one less than the number? Alright, so while k is less than or equal to 20, we're going to keep adding 1 to it. And like I said, you could use the postfix or the prefix increment. Either one will work the same. The question is just how the two of them work. Now I said I would explain the difference. We have our plus plus k. Now I could also do k plus plus. Both of these will function the same way, but the prefix operator is actually much faster. The reason for it is k plus plus is the same as saying k equals k plus 1. And what it does is it actually has to load in whatever the value for k is, then it will add 1 to it. But what happens is it displays k to our operation here, our comparison, before it adds the 1 to it. If we do the plus plus k, then what happens is it will add 1 to whatever's in the k location, then it does a lookup to see what's in k. And this type of operator here, our prefix, is actually the preferred version because it is much faster than a postfix. Alright, so I want you to go ahead and save this. This is number 3, and then we're going to modify it. So let's go to File, Save As, and let's save this as number 4. Okay, so now number 4, what I want to do is I want to actually make a multiplication table. And so what I'm going to do is I want it to be up to 12, and I want to make our multiplication table of 1 through 12 across the top and then 1 through 12 down the side, and then I want it to display the entire multiplication to me on the screen. To do this, I'm going to need to use a nested loop. Alright, so my outer loop is going to control what line number we're on. So this is going to be our line control number. And then our inner loop is going to control the values going across the screen. So what I want to do is not necessarily console.writeLine k, but inside of another for loop, which is going to look similar to the other one. And actually what I'm going to do is I'm going to call this k1, and then this one I'm going to call it k2. This is also going to start at 1, and it's going to go up to 12. And once again, we're going to increment k2. Now this is going to have a body that goes in the curly brackets, and I changed this to k1, so I also need to change this one to k1. So this is my outside counter, and this is my inner counter. Alright, so what I want to do is I want to start adding code to this that it will go through the loop to calculate the values across the page, and then it'll go to the second line to display those values across the page. Alright, so what you need to think about is my outer loop, the first time it runs through, is going to say 1. So this is going to be our 1. So I want it to do 1, 2, 3, 4, 5, 6, so forth across the page. Alright, so what we're going to do is we want to actually multiply these numbers. So 1 times 1 is 1, and then I want to say 2 times 2 is 4, and so forth. So we're actually going to make a multiplication table. Alright, so what I need to do is I need to use my inner loop to multiply whatever K2 is currently right now to K1, and then we're going to write that out to the screen. Alright, so what I'm going to do is something like a console.write, and I don't want to do a write line yet, because what I want it to do is not actually give me a new line, I want it to put across the page. Alright, so what I'm going to do is I'm going to put console.write, and then what am I putting? Well, I'm going to put K1 times K2. Now we'll make this look prettier in just a minute, but what I want it to do is I want it to go through our loop here, and I want it to write out whatever K1 times K2 is. So the first time we come through, we will have 1 times 1 is 1. This loop repeats, it increments by 1, so now we have 2. So now we have 1 times 2 would give us 2. Repeat, 1 times 3 is 3. Repeat, 1 times 4 is 4, and so forth. So we'll write those across the screen. Alright, so like I said, I'm going to run this, and we're going to let it not look very nice right now, but we'll fix it in just a minute. So what I want to do is I want to compile it. It was number 4. Okay, so now it says K does not exist on line 9 and line 11. Oh, so we have K here, so K1, and this is K2. Let's try it again. Alright, so now I want to run that. Alright, so we're going to run number 4. And now I get something that looks like this. Alright, so now what it did is it did actually put our numbers. So if I look across here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Then I have 3, 6, 9. So it is doing my multiplication, but the problem is it's cramming it all on one line. So what I want to do is I want to put this on separate lines. So after this loop runs, the next thing that I want to do is I want to create a new line. Alright, so what I'm going to do is I'm going to say console.writeLine, and then I can just simply do something like this. So we're simply not writing anything out to the screen. Save it, run it, compile it, and then run it, and now we get something that looks like this. So all I did was I just simply made a new line here by doing a write line command, not actually writing anything out to the screen, except at the end of each one of these there will be a new line character. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 all the way down, and if you notice it actually does go over to 144, so I'm getting the right values, but it's all crammed together. Alright, so what I can do is I can use my formatting commands to actually determine how things should be displayed on the screen. Alright, so if you remember from before, we were able to use our string formatting, and what I can do is I can put in quotes here, and I can say something like 0 in curly brackets, and we would display out this value. So let's try this real quick and see what we get. Alright, run it, and I get the exact same thing. But what I can do now is I can allocate space for every one of these. Now our value that has the longest length is going to be 3. So what I want to do is I want to allocate at least 3 spaces for each one of these numbers. Well, if I want a space between them, I actually want to allocate 4 spaces for each one to account for space. Alright, so I can use my formatting, and I can say 4. And the question is, do I want it right aligned or left aligned? And remember, the negative would be left aligned, and then a positive would be right aligned. So let's try both ways, and we'll see which one looks better. So compile it, run it, and now I get something that looks like a table. Alright, so now this is right aligned. Notice there is a space, because each one of these will take up 4 spaces, and I get these all nice and neat right aligned. Alright, so I want to make it left aligned. I just simply make it -4. Run it, and now they're all left aligned. Now what we expect as humans is we're used to seeing everything right aligned. We want our ones places lined up. So typically we're going to want this to be a positive number. That way they can be right aligned. And now we have something that looks like this. And this gives us our nice, neat multiplication table. We can go across here and see, okay, 9 times 7 is 63. So we do have our multiplication table now. Alright, our next program is going to be a GUI-based application. I want to redo the question about asking the user for numbers and then displaying the sum to the screen. So I'm going to make a new project, and this is going to be a Windows Forms application. Make sure you have C# selected, and we're going to call this Pringle _ week 6 _ number 5. We're going to let it create a new directory, and then OK. Now remember, with any of our forms programs, we're going to rename the form. So this is FRM main. Yes, I want to rename everything else. Okay, my form, I want to give it a different name. Sorry, not different name, but different text. So we're going to add numbers together. So this is what the program is going to be, add numbers. And what I want to do is I want to tell the user, enter a number, and they're going to put it into a text box. So we have our text box here. And then they're going to push a button to calculate some value. And then I want another label that will provide output for what the sum is. Okay, so our label here is just simply going to be enter a number. Okay, so we can enter a number. And then we're not going to rename this one because we're not actually asking them to do something that will programmatically change this. Okay, so our button here is going to be the button to calculate. So it's going to be calculate. And it's going to be called CMD calculate. All right, and then our label down here is going to be LBL sum. So this will display the sum. And then its initial value is nothing. Remember, we don't want this to show up at first. We want it to show up later when we actually programmatically add something to it. All right, so what I want to do is I want to add some code to this button so that way when the user enters a value into this box, then we can ask them for a number and keep adding it to it. All right, so I'm going to double click the calculate button, and that will create my method for the command click event. Okay, so what we're going to do is we're going to read in from the text box. Okay, so we read the value from the text box, and we're going to put it into a variable. Then we're going to take whatever our running sum is. So we're going to add the value to running sum. So we're going to make a register. And so I'm just simply making these just as a way to remind myself of what I need. So I have declare variables. Okay, so I need a variable to be my register. So in this case, it's going to be an integer, and I'm going to call it int sum. And we're going to start this off at some initial value of 0. All right, so then what we're going to do is we are going to read the value from the text box, and we're going to put that into a variable. Now, we could do this as 2 lines of code. So I could do something like string str. Let's see, we're going to call it, I forgot to rename this. So let's call it input number. So this is tbx input number. Okay, so I'm going to have a string value called str input number. And this is going to be equal to whatever the contents of the text box is. So remember, tbx input number dot text. Okay, so whatever the text value is will get put into str input number. All right, so then what we can do is we can take whatever's in str input number, and we have to convert that to an integer to stick it into another integer value. So I'm going to call it int input number, and we're going to set that equal to convert dot to int 32, and that's going to be str input number. So we take whatever is in str input number, convert it to an integer, stick it into int input number, and then we're going to take whatever is in the sum, whatever's in int sum right now, and we're going to add that value to it. So I'm going to say int sum, and I want to add whatever's in int sum plus int input number. So I can do plus equals int input number. All right, so now I have my sum, and at the very end of this, I am simply going to change the label to include the sum. Okay, so what I'm going to do is I want to take whatever the label value is right now. So I have lblsum.text, and I want to set that equal to string.format. And what am I formatting? Well, I'm formatting the sum is 0, period, and then int sum. Okay, I didn't create a loop. There's no loop here. And the reason there's no loop is I'm relying on the user to actually put the input in for me, and every time they click a button, they are causing it to perform it. So this is similar to the first program that we did, but in this case, because it's a GUI-based application, I don't necessarily need a loop. All right, so we have a register declared. We're going to read in whatever's in the text box, put that into str input number, convert str input number to an integer, put that into int input number, add whatever is in int input number to the sum, and then we output the sum is int sum. All right, so I start off, I'm going to enter a number, 5, calculate, the sum is 5. Okay, so I'm going to add 10 to it, calculate, the sum is 10. Okay, so now I want to add 20 to it and calculate, and the question is, why is it not replacing this with some other value? All right, so I'll show you what the problem is. The problem is I created a variable that exists only for the scope of this particular event. This variable is not available anymore. After this event runs, if it goes through all of this stuff, this variable no longer exists. So if I want to keep this variable, I have to declare this not here, but actually up here. I'm going to declare it before my form. Okay, so this is my global variable int sum. Now what this will do is it'll make this variable available to all of the methods that are here. All right, so we're still going to do the same type of function. We're still going to read in the input from the user in that text box, and then we're going to update our global variable called int sum. So now if I do 5 and calculate, the sum is 5, I add 10 to it, calculate, now it's 15, add 20 to it, now it's 35. So the difference here is going to be that I have to keep my variable as a global variable, otherwise its scope only exists until that method is over. All right, so I just did something where I'm asking the user for another number, but instead of saying, do you want to enter another number, or while the value is not equal to 999, what I'm doing is I'm leaving it up to the user that they can click the button to keep calculating it. In our object-oriented environment, we actually will use less loops because we rely on the user's input. But there will be times that we need to have a loop. So if we ask the user how many times they want to enter it, that will be a little bit different. All right, so your loops inside of the GUI-based application will function the same way as they do in the console if I actually need a loop. So if I had asked them how many times do you want to display hello, like the example in your book, then I need a loop. But if it's something where I'm trying to add up values, I don't need a loop. I'm relying on the user to click the button, and then they can decide if they want to add it again. Because now if I want to add that 20 again, I click calculate. So this would be the same thing as a loop running, but I'm manually doing it because I click the calculate button. In this lesson, you learned that a loop is a structure that allows repeated execution of block statements. You learned how to use a while loop, and that a while loop will evaluate the condition to be true before it performs the block. You use a for statement to make a definite loop. We have an initialized counter, we evaluate the counter, and then we increment the counter or decrement it. A while loop and a do loop are opposite in that the while loop performs the evaluation before the block runs. The do loop runs the block first and then evaluates the condition. We are able to nest our loops together, and we need to use accumulators to hold on to values. We also call it a register, and make sure that whenever you use a register that you typically want to create that as a global variable. we want to make sure that we can improve our loop performance. We want to make sure that we don't do any unnecessary operations. So if we're doing a calculation in our loop and we're doing that same calculation over and over again, consider moving that outside of the loop. And in the GUI-based applications, you can use the while, for, and do while loops, but many times you won't have to because we rely on the user to actually provide the input that we need.